Hello all, welcome to the day 64 of the daily case study series for CBSE grade 12. The question goes like this. Let's say that we want to evaluate integral p of x upon q of x dx, where p of x by q of x is a proper rational function. In such cases, it is possible to write the integrand as a sum of simpler rational functions by using partial fraction decomposition. Post this, integration can be carried out easily. The following image indicates some simple partial fractions which can be associated with various rational functions. A table has been given and there are two columns here: form of the rational function, form of the partial function. For each form of rational function, the form of the partial function is given. So the first thing what we have to do is we have to check the function that has been given to us, and we have to recognize which form of the rational function it is. Based on that, we will be applying the partial fraction. Suppose if the function given to us is of the form px plus q upon x minus a times x minus b, then it has to be decomposed as a upon x minus a plus b upon x minus b. Similarly, if the given function is of the form px plus q upon x minus a the whole square, then it should be written as a upon x minus a plus b upon x minus a the whole square, and so on. In the above table, a, b and c are real numbers to be determined suitably. After rewriting the integrand, we are not supposed to leave it as a, b, c itself. We have to compare the original form and the decomposed form and get the values for a, b and c. Question 1. Write the partial fraction decomposition of the expression 20x plus 35 upon x minus 4 the whole square. Now this is of the form px plus q upon x minus a the whole square. This can be rewritten as a upon x minus 4 plus b upon x minus 4 the whole square. So 20x plus 35 upon x minus 4 the whole square is equal to a times x minus 4 plus b upon x minus 4 the whole square. Now that the denominators became equal, so it can be cancelled. 20x plus 35 is equal to ax minus 4a plus b. Comparing the LHS and the RHS, a is equal to 20. Comparing the constants on both the sides, minus 4a plus b is equal to 35. Substituting 20 in this, we get b as 115. So 20x plus 35 upon x minus 4 the whole square becomes 20 upon x minus 4 plus 115 upon x minus 4 the whole square. Question 2. Write the partial fraction decomposition of the expression 1 upon x plus 1 times x plus 2. 1 upon x plus 1 times x plus 2. This expression is of the form px plus q upon x minus a times x minus b. So this expression can be rewritten as a upon x plus 1 plus b upon x plus 2. The next task is to make the denominators equal. 1 upon x plus 1 times x plus 2 is equal to a times x plus 2 plus b times x plus 1 upon x plus 1 times x plus 2. Now that the denominators became equal, it can be cancelled. 1 equal to ax plus 2a plus bx plus b. Putting the like terms together, we get a plus b times x plus 2a plus b on the RHS. Comparing the LHS and RHS, there is no x term on the LHS. So a plus b becomes 0 and 2a plus b becomes 1. Let's mark these as equation 1 and 2. 2 minus 1 gives a equal to 1. Substituting a value in any one of these two equations, we get b as minus 1. So the given expression can be rewritten as 1 upon x plus 1 times x plus 2 is equal to 1 upon x plus 1 minus 1 upon x plus 2. Question 3. Evaluate integral dx upon e power x minus 1. Integral dx upon e power x minus 1. Let's use the substitution method. T is equal to e power x. Dt upon dx gives e power x. So dt upon e power x becomes d. Substituting t for e power x, it becomes integral 1 upon t minus 1 into dx is dt upon e power x. This e power x also can be written in form of t. So 1 upon t minus 1 into dt by t. Rewriting this, we get 1 upon t times t minus 1 dt. By the partial fraction decomposition, 1 upon t times t minus 1 can be written as a upon t plus b upon t minus 1. Next task is to make the denominators equal. 1 upon t times t minus 1 is equal to a times t minus 1 plus bt by t times t minus 1. Now that the denominators became equal, they can be cancelled. 1 is equal to at minus a plus bt. That is 1 is equal to a plus b times t minus a. Comparing the LHS and RHS, a plus b is 0 and minus a is equal to 1. That is a is minus 1. Putting this a minus 1, we get b is equal to 1. Substituting a and b values, we get integral minus 1 upon t plus 1 upon t minus 1 dt. That is integral minus 1 upon t dt plus integral 1 upon t minus 1 dt, which gives us minus log t plus log t minus 1 plus c. By the logarithmic properties, we can rewrite this as log t minus 1 upon t plus c. Now substituting for t, we get log e power x minus 1 upon e power x plus c. So this is the answer for the question 3. Question 4. Evaluate integral 1 upon x square minus 9 dx. Integral 1 upon x square minus 9 dx. The integrand given is 1 upon x square minus 9. This can be rewritten as 1 upon x minus 3 times x plus 3. Now this is of the form px plus q upon x minus a times x minus b. So based on that, we rewrite this as a upon x minus 3 plus b upon x plus 3. Now the next task is to make the denominators equal. That is 1 upon x minus 3 times x plus 3 is equal to a times x plus 3 plus b times x minus 3 upon x minus 3 times x plus 3. Now that the denominators became equal, they can be cancelled, leaving 1 equal to ax plus 3a plus bx minus 3b. Putting the like terms together, we get a plus b times x plus 3a minus 3b on the right hand side. Comparing the LHS and the RHS. In the LHS, there are no x terms, which means a plus b becomes 0 and 3a minus 3b becomes 1. Let's name these equations as 1 and 2. Multiplying the first equation by 3, we get 3a plus 3b is equal to 0. Let this be equation 3. Adding 2 and 3, we get 6a is equal to 1. That is a equal to 1 by 6. Substituting a equal to 1 by 6 in any one of these equations, we get b as minus 1 by 6. We get integral 1 upon x square minus 9 dx equal to integral 1 upon 6 times x minus 3 minus 1 upon 6 times x plus 3 dx. Taking 1 upon 6 common, integral 1 upon x minus 3 dx minus integral 1 upon x plus 3 dx gives us 1 upon 6 times log x minus 3 minus log x plus 3 plus c. Using the logarithmic properties, this can be rewritten as 1 upon 6 times log x minus 3 upon x plus 3 plus c. This is the answer for the question 4. Here also we have used the partial fraction decomposition method. If you found this video helpful, don't forget to like, share and subscribe to my channel Math with Meenakshi for more smart learning videos. See you all with another case study question tomorrow.